This is Unit 1, Lesson 5, Least Common Multiple. Least common multiple is very important when you are adding or subtracting fractions. In the past lesson, all the denominators were the same in all the fractions we were adding and subtracting. You really don't have to worry too much about the math as long as the denominators are the same. But occasionally you'll get fractions where the denominators are not the same. The bottom number is not the same on both fractions. So you have to convert one of them. So sometimes you might have to convert both of them. So what we need to do is figure out how do we make a common multiple, a same multiple, and it needs to be the lowest number. It makes it easier on our lives when we pick the lowest number. So there's two ways you can go about doing it. The first way is to make a list. If the numbers are small enough, just make a list of what numbers you can get by multiplying the number by just go in order 1, 2, 3, 4, 5. So let's look at number 1. We'll look at the number 2 here. What numbers can I get if I multiply 2? Starting with the number 1. 2 times 1 is 2. 2 times 2 is 4. Let me make this a little bigger. 2 times 3 is 6. 2 times 4 is 8. Oh, well, I'm starting to see something there. Let's do one more. 2 times 5 is 10. Now let's do the 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. I don't think I need to go any further because I already see a match. 8 and 8. So 8 is the lowest number that 2 and 8 go into. Okay, because 2 times 4 is 8, 1 times 8 is 8. So I'm looking for one number that both numbers go into. Let's look at number 2 here. 3 and 5. Well, let's look at 3 first. 3 times 1 is 3. 2 times 3 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. Let's stop there. Let's do 5s. 5 times 1 is 5. 2 times 5 is 10. 3 times 5 is 15. Whoa, I see a match. As soon as I see a match, I know that's the least common multiple. So 15 is the least common multiple there. Okay? Once you pause the video and try to do number 3 on your own. Okay, number 3, 8 and 10. Well, let's make a list. Again, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. Okay, I know my multiplication table well enough that I can see a match coming up already. Let's go ahead and do the 10s. 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. 10 times 4 is 40. As soon as I saw that number with a 0 on the end of it, I knew 10 went into it. So I know the least common multiple is 40. Okay? Let's go to the next one. I know it says this one's also 3, but this one is actually number 4, and this one is actually number 5. Let's look at 4 and 9. Now, there's another way to do this. Sometimes it can take a while to count up to a number that both of them go into. But the simplest way is to just multiply them together. So if I multiply 4 and 9, I get 36. So 4 times 9 equals 36. And then I got to think about, okay, is there a smaller number, the lower number that both numbers can go into? Well, if I check that, and I could maybe look at a multiplication table and go, okay, if I look at my 9 row and my 4 row, what number appears first, numerically? Well, I know that the only numbers that 9 goes into is 9, 18, 27, 36. 4 does not go into 9. 4 does not go into 18. 4 does not go into 27, but 4 does go into 36. I can divide 36 by 4 and get a whole number. And 36 divided by 4 is 9. So 36 is my least common multiple. Again, over here, 6 and 21. This one can be a little bit more difficult, but sometimes it's not as hard as you think. Now, I could multiply 6 and 21, And that would give me a pretty big number. But again, let's do the list thing. So let's go 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. Now, in my head, I can see something coming up already because I know my multiplication tables pretty well. Let's do 21. 21 times 1 is 21. 21 times 2 is 42. Guess what? That is the lowest number that both numbers go into evenly. I could have also multiplied it. 6 times 21 would have given me 126, but then, and that would have worked. It would have worked for our fraction, but I want to reduce that to the lowest number that both of the numbers would go into. And that would have been 42. So let's go on to the next one. 9 and 15. That one can be a little difficult. Again, start making lists. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. Something hits my brain right here. I see that 5, and I know that's 5 can go into 15. I also know 5 can go into 45. Let's see if maybe that's our least common multiple. Because 15 times 1 is 15. 15 times 2 is 30. 15 times 3, 45. There's our match. So 45 is the lowest number that both numbers will go into, or least common multiple. Okay. Let's look at this next section. Adding and subtracting fractions with unlike bases. That's what this whole lesson is about. So the first thing you need to do, here's the steps. If there's a mixed number, write it as convert it to an improper fraction. That's the thing where we multiply and then add. Okay? That will convert it to an improper fraction if it's got a whole number with it. Determine the least common multiple of the denominators. What number will both denominators go into evenly? Then rewrite the fraction using the LCM as the denominator. Adjust each numerator to reflect the change in the denominator. So I'll show you what that means here in a second. Add and subtract the numerators just like we did in the last lesson, and keep the common denominator. That's what we did last lesson. We didn't worry about the denominator because they were always the same. Now we've got to convert. And then simplify. You guys got to remember, always simplify. Don't leave a fraction out there that can be simplified or lowered, okay? So let's look at number 7. What are the numbers that 9 and 3 both go into evenly? Well, let's start our list. I'm going to start with the smaller number first. So I've got 3 times 1 is 3, 2 times 3 is 6, 3 times 3 is 9. Oh, wait, 9. Those two match. So if one number goes into the other denominator, if one denominator goes into the other denominator, a whole number, an even number of times, I can use that. So all I need to do is take this fraction and convert it so it has a denominator of 9. And that's real easy to do. I've taken 2/3. I need to convert it so that the denominator is a 9. Well, what do I multiply 3 by to get 9? I multiply it times 3. Now here's where you got to be careful. I can't just multiply the denominator by 3. I also have to multiply the numerator by 3. Because technically, I'm multiplying by, what is 3 divided by 3? It's 1. I'm technically multiplying by 1. I'm not changing the value of the fraction. I'm changing the numbers within the fraction. They're still going to have the same value. So multiply straight across. So 2 times 3 is 6. 3 times 3 is 9. I can now use that fraction in place of the 2/3. So let's rewrite our original equation, or original expression here. 11 over 9 plus 6 over 9. Now it's a lot simpler. It's just like the last lesson. 11 plus 6, that's 17. The 9, the denominator stays the same. Now, I got to figure out how many times does 9 go into 17. Well, I know 9 goes into 17, not twice, because that'd be 18. It would go in one time, so that's my big number. I take the 9 out of the 17. I'm always going to have that unless I have a whole number, or a match. So if I take 9 out of 17, what am I left with? 8. Okay, so I get 1 and 8/9. And 8/9, I can look at that and I go, there is nothing that goes into 8 and 9 to where I can simplify it or reduce it. So 1 and 8/9 is my answer. Let's look at number 8. I've got a 4 and a 7 as denominators, 3/4 plus 9/7. I got to come up with something that both numbers go into. Okay, now I can multiply them together, 4 and 7. 4 times 7 gives me 28. Is there a smaller number that 4 and 7 go into? Well, the only numbers that 7 goes into is 7, 14, and 21 that are smaller than 28. And 4 doesn't go into any of those evenly. Okay, so 28 looks like that's the number I need. So I need to convert both of them. So to get 3/4, what do I multiply 4 by to get 28? I multiply it by 7. So I'm multiplying by 7 over 7. And remember, fractions are just little division problems. 7 divided by 7 is 1. So again, I'm technically multiplying by 1. I'm not changing the value, I'm just changing the numbers. 3 times 7 is 21, 4 times 7 is 28. Okay, so that's going to take the place of my 3/4. The next one, 9 over 7. Well, I need to multiply by 4 in the numerator and the denominator. That's going to give me 36, 36 over 28. So now that is going to replace this. So now I have 21 over 28 plus 36 over 28. And if I add them straight across, 21 plus 36 is 57. And I leave the denominators alone. I don't mess with it. Okay? Now I got to figure out, this is an improper fraction. I've got to convert it to a mixed number with this in the simplest form, or the reduced fraction. So 28 goes into 57. I know that's 2 times. It goes in, 28 times 2 is 56. So it's 2. And if I take 56 out of 57, I'm left with 1/28. There's my answer. Okay, let's move on to, actually, let's see, yeah. I'm going to do one more with you. So, I've got this negative 5/6 plus 3/8. So I got to figure out what number does 5/6 go into, or what number does 6 go into that 8 also goes into evenly. Again, you may have to look at a multiplication table or maybe even use a calculator. If I multiply them together, 6 times 8, I get 48. That seems like a big number to me. Maybe I could cut that in half and see if both numbers still go in. Well, what's half of 48? Half of 40 is 20. Half of 8 is 4, so that's 24. Does 6 and 8 go into 24? Yeah, 6 goes in 4 times and 8 goes in 3 times. So 24 works. What if I cut it in half again? 12. Well, 8 doesn't go into 12, so we're going to use 24. So how do I make these into denominators both with 24? Well, let's put the negative 5/6, and we don't really have to worry about the negative right now. It's just going to go along for the ride, because all I got to do is multiply the top and bottom by 4 to get 24, and I'm still going to have a negative. 5 times 4 is 20. 6 times 4 is 24. Okay, so that's going to take the place of this 5/6, negative 5/6. 3/8. Well, what do I multiply 8 by to get 24? Well, 3. So I'm going to multiply that by 3, not by 3. Remember, when you multiply, you have to multiply the numerator and the denominator by the same number, or you're totally changing the value. You don't want to change the value. You just want to change the numbers. 3 times 3 is 9. 3 times 8 is 24. Whole reason we did that. So now we have 2 fractions we can use, because this is going to take the place of that fraction. So now we have negative 20 over 24 plus 9 over 24. We combine the numerators. It's a negative. We're going to use that negative with the 20. Just move the negative so it's with the 20. Okay, let's just assume it's a negative 20 on the top. Negative 20 plus 9. If I start at negative 20 on the number line, way to the left of the 0, and I add 9, that means I got to go right on the number line, 9 spaces, I end up at negative 11. And the denominator stays the same. Now, here we're kind of lucky. There are no numbers that 11 or 24 go into that are the same. I can't reduce it. I can't divide 11 by 2. And there's the only two numbers that go into 11 are 1 and 11, and I don't care about 1 because 1 won't change it, and 11 doesn't go into 24. So that is our final answer. Okay? Go ahead and try the next 3 on your own and pause the video. Okay. I'm going to give you the answers to the next 3, so you might want to check them. So on number 10, the answer, you should have ended up with negative 53 over 5, or after you convert it to a mixed number, you get negative 10 and 3/5. Number 11, you should have gotten 211 over 24, which would, or that would give you 8 and 19/24 once you convert it to a mixed number. Number 12 would have been 247 over 40, oops, or once you convert it to a mixed number, 6 and 7/40. Okay? Hopefully you did pretty good on those. Let's go on to the back, show a couple of more. Now on the back, and I probably should have helped you out on these. Actually, let's do this. I'm going to show you how I got numbers 11 and 12. Because I think that could help quite a bit. Actually, I'm going to go back and I'm going to give you the answers, or I'm going to show you how these answers came about. That'd be better. So, first off, number 10. I got negative 12. Well, that's not a fraction. Well, technically it is a fraction. Any whole number, you can put it over 1. Now I've got a fraction. Well, are my denominators the same? No, I've got 1 and 5. Now, you can only do this if there's no fraction with the whole number. So negative 12 didn't have a fraction with it. So it was just a whole number, so I can just put it over 1. Well, what number does 1 and 5 both go into evenly? 5. So if I take that negative 12 over 1, how do I turn that 1 into a 5? I multiply it by 5. So I got to multiply the top and bottom by 5. So that's going to give me a negative 60 over 5. So now I have negative 60 over 5 plus 7/5. That equals negative 67/5. And again, if I get that negative 67/5, I need to reduce that. Oops, I'm sorry. I totally messed that up. Negative 60. Hopefully somebody caught that. If I'm at negative 60 and I add 7, I'm at negative 60. I'm way to the left of 0. I add 7, I got to go right. So I'm counting to the right or down backwards from negative 60. That gives me a negative 53. I'm sorry. That was my fault. I got a little ahead of myself, and that happens. You can end up kind of messing yourself up. So if I want to reduce that, now that's an improper fraction. I need to convert it into a mixed number. 5 goes into negative 50, negative 10 times with 3/5 left over. Okay, so either one of these answers, depending on how they word, whenever you see a test, if they say convert it to a mixed number, you might want to always convert it to a mixed number anyway, because it's more proper. This is a little more right than the other way, than the negative 53 over 5. Okay? Again, let's look at number 11. 11, we need to convert everything to an improper fraction. Remember, we multiply, and add. Multiply and add. So my first fraction is really 3 times 2 is 6, plus 2 is 10, so I have 10 thirds, plus 8 times 6 is 48, plus 1 is 49 eighths. Okay, I don't have a common denominator, but I got to get one. Well, what number is the smallest number that both 3 and 8 can go into? Well, let's think about it. What's 3 times 8? That's 24. I know that's a number that 3 and 8 goes into evenly. But is there a smaller number than 24? Well, no. 8 doesn't go into any numbers that 3 also goes into that's less than 24. So we need to convert both of those numbers to using 24. We need to convert them both to a denominator of 24. So 10 thirds, I multiply 3 times 8 to get 24, so I have to multiply the top by 8. So that gives me 80 24ths. I need to convert the 49 over 8. Well, what do I multiply 8 by to get 24? That's 3, so I also have to multiply the top by 3. And 3 times 49 gives me 147 over 24. Oh, and I made another mistake. My gosh, it's early. Hopefully you caught that. 3 times 2 is 6, plus 2 is 8. Man, I'm just off today. So it should be 8 thirds. 8 thirds. So that is 64. Oh, I hate when it does this. Let's make a smaller eraser here. So 8 times 8 would be 64 24ths. So now I have, sorry about that, I have 64 over 24 plus 147 over 24. Okay, so now I think we're on to it. Okay, sorry about all that. Go back, double check that, fix it. Numbers over here now correct. Okay, it should all be 8. So 64 plus 147, that is 211 over 24. The denominator stays the same. Or if I convert it, I know 24 goes into 211 8 times with 19 left over after I take out 8 times 24. And 19 and 24, there are only 2 numbers that go into 19, 1 and 19 does not go into 24, so we're done. That is that problem. So here's what I want you to do. Sorry about that, but on the back, try to do, let's just do a couple of examples. I want you to try 13 and 16. Do that one on your own, those 2 on your own. And then do 19 and 22 on your own. Okay, so those should be completed by you. Again, if you got confused on anything, and I apologize for that one problem, I got a little ahead of myself. But if you look at it, even I make mistakes. It's okay to make mistakes on these things, and as long as you go back and fix them and understand where you made your mistake. Okay, so double check your math. That is it for the notes for today. There's a homework page for you to do. If you have any questions, either email me or ask me in class, and I will talk to you next time.